Most people don't realize just how underrated Heinz Baked Beans are. They're packed with fiber, and they've got a surprising amount of vitamins and minerals for something that comes out of a can. Meanwhile, a lot of people treat donuts like the default breakfast. If you want a more balanced side, baked beans are honestly worth considering. But what really makes them worth it isn't just the nutrition, it's the consistency. Every can opens the same. The beans are always tender, the sauce is always thick, and the flavor is almost identical every single time. And to pull that off, the factory uses something that sounds like it came out of a movie, but it's 100% real. A spy can. It looks like a normal can, but inside it has sensors that record the temperature every second, and that data decides whether the batch passes or needs adjustments. Now let's head into the plant and see exactly how Heinz Baked Beans are made. The beans used for baked beans are navy beans, which are part of the common bean family, a real pantry staple. They grow low to the ground, hugging the soil as they mature. For Heinz-style baked beans, some of the most consistently good batches are often said to come from Michigan in the US. In the spring, around May, once the soil warms up and conditions are just right for beans, farmers plant the seeds. About 6 weeks later, the plants reach roughly 2 feet tall and start to flower, kicking off the pod-forming stage. Inside those pods, the young beans gradually develop, protected by a thick, sturdy shell, basically like a little suit of armor while they grow. By around day 90, the beans are just right for harvest, and a combine harvester handles almost everything in one pass. It cuts the plants, separates the beans from the stalks and pods, then loads the beans straight into a truck. From there, the beans head to a processing facility for a final cleaning. They're poured onto screening and sorting systems to remove dried leaves, broken stems, and any leftover debris. Once they meet spec, the beans get packed into jumbo 2-ton bags, loaded into containers, and shipped across the ocean to Heinz's plant in Wigan, where they'll be cooked and mixed with that signature tomato sauce. Every morning at the Heinz plant, around 160 tons of dry haricot beans arrive by sea from farms in Michigan, ready to kick off the baked beans production line. The beans are packed in 2-ton jumbo bags, and each truck usually hauls about 10 bags per trip. At the unloading area, workers are dealing with some seriously heavy raw materials, so they use mechanical lifting equipment to raise each bag and carefully position it over the opening of a large feed hopper. Once everything's lined up, they pull a release cord, and the dry beans start pouring down in a steady stream. Right underneath the hopper, there's typically a vibrating unit running to keep the beans from clumping up or getting stuck. From there, the beans ride a conveyor straight into the first step, washing. In this stage, the beans are washed to remove any dust, dirt, and grit left over from the farm. The water is set up to create a swirling flow that knocks loose debris clinging to the surface of the beans, while lighter bits of trash float up and get skimmed off. The heavier beans sink, and the moving water pushes them through the system, while the wash water runs through a coarse filter to catch sediment before the beans move on to the next step. When the beans first arrive at the plant, their moisture content is usually under 10%, which means they're rock hard. So before they can be cooked in sauce, the factory has to rehydrate them and bring that moisture level back into the right range. The first step is softening them with hot water, a process called blanching. The beans move through blanching chambers, where steam and hot water hit them directly to loosen that tough outer skin and let moisture slowly soak into the center. This step also helps preserve their color, flavor, and some of their nutritional value. The beans are blanched for about 20 minutes. It's long enough for them to noticeably plump up, but it stops short of actually cooking them through. Right after that, the beans move into a cool water tank to bring the temperature down fast. That prevents any carryover cooking, and it also helps separate some of the skins that have already loosened up. Because the beans have absorbed water, they get heavier and sink, while the lighter skins float to the top and spill over the edge with the wastewater. Finally, the beans pass over a vibrating conveyor where they get shaken hard to knock off any stubborn grit or tiny bits of debris that slipped through earlier. Next, the beans are checked to make sure they're all the right color. To ensure only beans that meet spec end up in the can, the plant uses a piece of equipment called an optical sorter. Inside the machine, an electronic eye tracks each bean as it flies past at high speed, constantly scanning and comparing color and surface quality to decide whether it makes the cut. If the system spots a bean that's discolored or off-spec, it instantly triggers a precise burst of compressed air that knocks that bean out of the mainstream and into a reject bin. While the optical system is inspecting every single bean and kicking out anything discolored, another part of the plant is working in parallel to keep the line moving. The tomato sauce is being made at the same time. Blocks of pure tomato concentrate come in from multiple sources, including Portugal and California. They're dumped into a large tank and blended with water to bring the mixture back to a standard concentration. Above the tank, there's a feed hopper loaded with dry ingredients like starch, sugar, and salt. That dry mix drops into the supply line and into the tank, where it's stirred for about 3 minutes to build the sauce's base thickness. Once the texture is set, workers add the special seasoning blend, packed in small containers. The exact recipe has been kept secret since 1901, and it arrives at the plant as 3 different powders, with each batch measured out with precise weights. Next, everything goes into the mixing system and is blended for around 15 minutes so the ingredients fully combine. The goal is a smooth, consistent sauce, while still holding on to a good amount of vitamin C, which helps your body absorb the iron in the beans. A single batch like this can be enough to fill up to 20,000 cans of beans. Before anything is cleared to move forward, the plant runs quality checks on the sauce to make sure every measurement stays within spec, especially sweetness and saltiness. Not too much, not too little, but dialed in exactly right so that once it meets the beans in the can, the flavor comes out unmistakably Heinz. Once the tomato sauce has been dialed into spec and kept warm in holding tanks, ready for filling, another part of the plant is running at full speed, the can-making line. At peak output, it can crank out around 2,000 cans per minute. Large metal sheets arrive from multiple countries around the world, including China and Brazil. They're fed into a cutting machine that slices them into rectangular blanks. Each rectangle will become the body of a single can. Next, those rectangular pieces move into a forming machine, where they're wrapped around a cylindrical core and rolled into a tube. Right after that, the long seam along the side is welded shut, creating a solid can body that's strong enough to hold its shape without splitting or popping open. Once the can body is stable, it goes through a stiffening station where raised ribs, called beads, are pressed into the metal to reinforce the walls. That extra structure helps the can handle the stress of the next steps. At the same time, the can ends are being made from separate metal sheets. A stamping press cuts and shapes them into perfectly sized circles, so they match the can body exactly. Finally, once everything is ready, the bottom is sealed onto the can body using a tight seaming process, creating a complete can. From this point on, it's ready to move onto the filling line, where it'll be filled and sealed to become the finished product. Once all the ingredients are ready, the plant's newest line kicks into rhythm, running at about 25 cans per second for filling and sealing. Empty cans come in as large blocks, moving steadily at around 1,500 cans per minute, and head straight into a pocket filler system. Here, the machine drops beans into each can using individual metering pockets, designed to release the exact amount of beans on every fill. The accuracy is tightly controlled, with a margin of error of only about 1 gram, so every can stays consistent. The amount of beans in each can matters more than you'd think, because it directly affects everything that happens next. How the product heats up, how tender the beans end up, how well they absorb the sauce, and even how safe they are for storage. Too many beans, and the batch might not reach the proper cook target in the process. Too few, and the quality and eating experience shift off-spec. That's why the system is constantly monitoring the fills, and if a can is even slightly out of range, a pneumatic arm immediately knocks it off the line and into rejection. Right after the bean portioning step, the cans move into high-speed sauce filling at around 1,200 cans per minute. The filler is calibrated so each can gets exactly the amount it needs, Not so much that it overflows or throws off the ratio, and not so little that the product ends up feeling short. At this point, what's inside the can still isn't fully cooked yet. Next, every can is sealed completely before it goes any further, because the main cooking step actually happens inside the can. And since that cooking happens later in the process, most of the ingredients coming into the plant are usually partially pre-processed ahead of time, so that once they're sealed and heat-treated, they hit the right tenderness, thickness, and consistent flavor can after can. Once the cans are filled and completely sealed, they're ready for the most important step: cooking thousands of cans at the same time, right inside their own cans. The plant doesn't need artificial preservatives to keep the beans fresh, because it relies on a standard food safety method used across the canned food industry called thermal sterilization. In this stage, the temperature inside the can is brought up very high, above 248 degrees Fahrenheit, to destroy microorganisms and make the product safe for long-term storage. The cans move into a sterilization chamber filled with superheated steam. In this tightly controlled environment of pressure and heat, the beans and sauce cook right inside the sealed can. The process usually runs through multiple step-up heating stages, followed by cooling stages that bring the product back down to a stable condition before it exits the system. That high heat knocks out bacteria thoroughly and keeps the food safe all the way until you pop the lid. To make sure the temperature inside the can actually hits the exact target, the plant also uses a spy can. It's filled with beans and sauce just like every other can, but it has an ultra-sensitive temperature probe and a small data logger sealed inside. Think of it like a thermometer that records the temperature over time throughout the entire sterilization cycle. Technicians can monitor the readings to confirm the can followed the required heat curve and make adjustments if needed. Because the cooking happens in the sealed environment of the can, a lot of the nutrients in the sauce are preserved more effectively, while the beans still keep the right structure and tenderness. And once thermal sterilization is complete, the baked beans can be stored safely for a long time, often up to around 2 years. Once the beans and sauce have been cooked inside the fully sealed cans, they move into the labeling area, where the product starts to take on the familiar look you recognize on a grocery shelf. The cans feed straight into high-speed labeling machines, with each one handling about 600 cans per minute. With 2 machines running side by side, total output hits roughly 1,200 cans per minute. Each label is wrapped precisely around the can body and aligned straight, so when they're stacked on shelves, every can looks consistent and professional. Right after that, the cans pass through a vision system, basically an automated inspection station. Cameras read and verify the label information to confirm the correct label was applied to the correct product, in the correct position, and facing the correct direction. Next, a tasting team pulls random samples to make sure the finished product hits the flavor standard. This step matters because no matter how advanced the machinery is, the final product still has to taste good to real people, the customers who'll be eating it at home. Cans that pass inspection move on to the packing and stacking area. On the conveyor, they're grouped to spec and loaded into trays as 4-packs or into 24-can cases, then run through a shrink wrap machine that tightens everything down so the packs stay secure during shipping. From there, they head into the palletizing zone, where robots take over the heavy lifting. Each lift grabs about 40 cans at a time, arranged as 8 cans per row, then repeats a precise sequence to stack up to 6 layers, building a pallet that's neat and rock solid. Once everything is wrapped and stacked, there's just one final stop before the product leaves the plant: the shipping area. This is the last stretch of the process, handling around 2,500 pallets every 24 hours. From the factory floor, pallets move straight into a massive distribution center next door, where automated cranes and material handling equipment run 24/7 to sort, store, and stage loads for trucks, ready to send baked beans out to stores across the country. And at that operating scale, the plant can produce up to around 1 billion cans per year. Heinz Baked Beans are now ready for you to grab a can of your own at the grocery store. Next time you pop open a can of Heinz, just remember you're opening up a whole massive production line behind it. How do you usually eat baked beans? With toast, with hot dogs, or just dumped straight over a baked potato? Thanks for watching Food Tech Today. I'll see you in the next episode.